Hello everyone, and in this video we're going to be looking at a past paper question, graph question actually, for the electric field chapter. So this is summer 2016 paper 4-3, question number 6. The question reads: a solid metal sphere of radius r is isolated in space. The sphere is positively charged so that the electric potential at its surface is Vs. The electric field strength at the surface is Es. And then the first part says, on the axis of figure 6.1, show the variation of the electric potential with distance x from the center of the sphere for values x from x equals 0 to x equals 3r. Now there are a few things before we jump on into the making the graph. Is number one is that potential over distance gives you electric field strength. Right? Electric field strength, and this is the potential gradient. First thing that you should know. Second thing you should know is that within a sphere, if this is a sphere, within the sphere in its radius, the potential, electric potential V, it remains constant and maximum. And number two, the electric field strength it remains 0. Right. So the graph they're asking us to draw is number one, there's just one metal sphere, there are no two metal, there are not two charges, no two unlike or like charges, so we're just going to forget about these four graphs that we started. In this we have to deduce a graph, make a graph on our own with the information that we have. So here it says potential, and here this is distance x, this is 3r, this is 2r, this is r, and this is 0, and here it's 1 Vs, and then it decreases to 0 0.2, 0 0.4, 0 0.6, and 0 0.8. Now they want us to make a graph for the electric potential from this to 3r. Now what I want you to know that first this is the radius, and what I just said is that in the radius the potential it remains constant and maximum. So what is the maximum value here? 1. That is the maximum value, and it has to remain constant. That means it will remain constant to 1 Vs for this radius. And now the moment it gets out of this, what do you think will happen to the gradient? First it's maximum and constant, and then it starts decreasing. Why? Because if you look at the formula for potential, it's Q over 4 pi E naught R. So when the radius it decreases, the V increases. So when radius increases, V, so they have like an inverse relation. So here R, which is x, that is increasing, so this will be decreasing. Now there are two things that should come to your mind. Should it decrease like a straight line, or should it decrease like this? How do we determine that? We know that the gradient will give me the electric field strength, right? Now the electric field strength is, the gradient is not constant, because the gradient is the electric field strength, and electric field strength is decreasing. So the electric field strength has to be decreasing for us. The gradient has to be decreasing gradually, and then it reaches. So you have to form a rough and then you just draw it like this. It should not be touching 0, because electric field strength doesn't get 0. And I hope that made sense. And now for the B part, B part says, on the axis of figure 6.2, show the variation of the electric field strength with the distance x from the center of the sphere for values x, and then again. Now this graph is for electric field strength against distance. Again the same thing, you have 0, then you have r, then you have 2r, and then you have 3r, and here it is 1.0 e, it's 0, and then it's 0.2 e, 0.4, 0.6, 0.8. Now what happens? If we go back, I just said that the electric field strength in the radius, it remains 0. So as long as it is inside the sphere, the electric field strength is 0, which means you're going to draw a straight line here. The electric field strength has to stay 0 for this part because this is the radius. But the moment it steps out, it goes to the maximum. It shoots up, it goes to maximum. And then what happens to electric field strength? Electric field strength gradually decreases, and you just have to make a curve like this. Now, I wanted to note something here. In this graph, we said that the electric field strength, the gradient is decreasing, which means the gradient is electric field strength, so electric field strength is decreasing. And here, the electric field strength is decreasing as well, because if you look at the formula for the electric field strength, Q over 4 pi E naught R square, right? So if you look at this formula, then obviously so when you have 1 over R square, whenever you have square, this is how the graph looks like. So again, they have an inverse relation. As as R increases, E decreases. So this is just happening. This is what is happening here as well. So whenever you have graphs, look at the y-axis, x-axis, see if what will the gradient look like, what will the relationship look like between them, and that is how you can get these it gets easier for you to draw these graphs. And I hope this made sense. If you have any questions, feel free to comment them down, and I'll get back to them as soon as possible.